This is Navika Academy, and we are going to do introduction to Linear Algebra 1, Linear Algebra 1, and we want to look at linear transformation. We want to look at linear transformation. So be keen on this because this creates basis of every part, both applied mathematics and pure mathematics. So real analysis is the key, is the theme, is the root for mathematics. Make sure every step you understand and you take notes on it. If you have not subscribed to this channel, again kindly subscribe so that every time I post anything in this channel, you are the first to get notification. Again, share with your friends so that they get to understand, to gain this knowledge. Knowledge is there to be shared. Remember this linear transformation. So we start with alcohol. If you have this kind of transformation where V, the transformation of T is mapping V to W and S mapping W to U, those being linear transformation, then if we change basis of ST from base E to G, then it's like breaking S and T in this form respectively. That T, you might want to go from E to G. So T carries E to F, E to F. And then S now takes F to G. We work from the left hand side. So we are having E, F, G. We want to go to G here. So the first part of D, T, will move the first thing to E, to F, and then F to G. Remember the common basis for this, in this case, is for V is E, for W is F, and for U is G. So if you look at T, T moves from V to W. V is actually E. W is actually F. And therefore that's the reason we have this part here. We have that part there. Then S is from W to U. W is F and U is G, and ends this that operation. For example, let's look at an example. If you have this transformation here, which by look, the domain is 3, therefore is divided by 3 variables x, y, z. Then it is mapped to a range of 2. Therefore, the operations will be 2 bits. Hence, that. And again for S, which is domain R2, so 2 variables, and then R4, 4 operations. 1, 2, 3, 4. Now we are given basis, of course. The basis for this for R2 is given here. That's like EI. R2, R3, the bases are given Fi, and R4 is their standard basis, which are GIs. So you want to work these operations, that, and this. Then after that, we show that this operation is simply breaking these two. It's simply like breaking these two. Of course, we don't have this operation here. The operation is there. Sign dot. Stand dot. Because our operation here is dot, side dot. Okay. So let's start from first part. Now you want to work st. This will mean what? We are moving s, then t. So the operation for s is r squared, and r squared is going to r4. It's moving up to r4. Then t is moving from r3 to r2. We see that from our example, the definition given from the example. So that we remember the operation starts from right hand. We move from right, moving left. So our t, let's consider t. T is mapping from where? So you look at the domain for t. And the domain for t is actually r cubed. Then it is going to, after t, the next operation is s, transformation in s. Transformation in s is taking r squared to r4. So the final solution will be the range of r4 as defined in s. So that's how you define that. You start from the left hand side, you have to look at the domain for t. Then the next thing is look the domain for the range for s, because s gives us the final output. Now, having known that, after finding this transformation, it will imply that our domain is in this product, in this operation st, is that it will involve three variables, which are x, y, z, as per the domain r cubed. Then that means opening the brackets, or else distributive property being applied, you see that this can be broken to that. So that after looking at this, you find this st here. This is operation in t transformation, which of course breaks to t maps r cubed to r2. We know that. This r2 domain is divided by which of products? Those and that. That and that. Now we are done with t. We now go to transformation. S transformation is given by r squared to r power 4. Now the operation of s, this is equivalent to s y x y. That will mean in this part, this is equivalent to x, and this is equivalent to y. That means now in the operation it is mapped to a range of 4, which is x plus y, x minus y, negative x plus y, and a 2x plus 3y. Remember all these, we have just looked at them, they are basically here. So substituting respectively, where you have x, we will put 3x plus 2y minus z as per this operation, and where we have y, you substitute with x plus y plus z. Then you'll find that this is true. Remember, in case you find difficulty in substituting this, you can leave a comment. I'll be able to show you how I have substituted into this. Of course, I can show you one. Now, the first operation is x plus y. Now we are saying x in our case now become 3x plus 2y minus z. Then y in our case become x plus y plus z. Now hand this, sum that. What are you getting? You can see you are getting 4x plus 3y, and therefore that part. Do the same for the others and you find that. Now remember that will become now the output for A, for this transformation here, for that transformation. You have a comment? Kindly leave a comment down there, and remember to subscribe. Let's look at another example, another part. We are using the transformation of t from f basis to e basis, Now we are transformed from f to e basis, How do we define f? So we are dealing with e, and the basis in e are defined by 2 characters. That's the reason we are using AB here. Okay, we are using the E is given by R2, 2 characters. So the product that we want to get is in 2 characters, which is AB. But we are transforming E, we are transforming F to E. We are transforming a 3 character vector to 2 character vector. So now you need to come up with a relationship. So the output will be 2 characters. So we make this as the output, the solution to be AB, the output. So we take the first E, okay, the first E1, okay, E1, and we relate with second E as defined, as given in our question, in our example. This is all to create a relationship. This is basically to create a relationship between the two bases. So the question that you need to ask yourself here, what do I expect to be the output? What do I expect to be the output? The final output is E, that is basis 2. So the product is AB. The output will be AB. So creating that relationship, you find this is true. The relationship is true. So that now we are using T, the transformation T, which is moving R cubed to R2. The range is R cubed and the output is R2. So if you do first TF1 is given. TF1 is T111. Now 11. So what is the definition for T11? Is x, y, z. Our x now in this case is 1, y is 1, z is 1. So substituting to 3 to 3x plus 2y minus z, you can see we have 3 plus 2 minus 1, which is basically 4, and else this 4 here. For 3, for other parts is x plus y plus z. X plus y plus z. Our values are 1, 1, 1. So 1 plus 1 plus 1. You see we are getting 3, and else this 3 here. That 3 there. So this means what? Our A in this case is comparing this with this. So our A is 4, and our B minus 2A is actually this. So that's first part solution. We have confirmed, we have transformed F basis 1, A1 to E1, to those two E bases. Now do F2, it's defined, again it's defined, and see it defined here, 1, 1, 0, 1, 1. So doing the same, you get that is true. Then F3, applying the same technique, you find this is true. Now, T, the operation that we have here, T to F to E, is basically a matrix. So how do you arrange this? How do you arrange this? Every base, F1, gives you a column. So therefore, 4, negative 1, as you can see there. 1, 0, 1, 0. Negative 1, 3. Negative 1, negative 3. Let's look at this, see whether this is working out. Is this working out? Is this working out? Okay, so here we have 1. You substitute there. We are going to get negative 1. Okay, and if you substitute there, we are going to get 1. That's true. Then B is actually 1. Take away 2, negative 1. So this becomes positive 3. Okay, so that's the answer for that. Positive 3, and as this is true. So that one is true. So we have done B. We have done B. Let's go to C. To C. C now. If you look at C now, we are transforming S from which base? From base E base to G. From E to G. So the final product is G's. The final products are G's. Okay? G's are the final bases that we want to transform. So what we need to do is we use a very particular given E's, and we change them to transform to G's. So that's okay. We are using G's as standard basis. So we just use different, just G direct. Therefore, for E1, 1, 2, 1, 2. So 1, 2. Definition of S transformation. S, X, Y, XY. XY is X plus Y, X minus Y, negative X plus Y, 2X plus 4. So we expect 4 solutions. So the first one is X plus Y. So when X is 1 and Y is 2, we expect we have 3. And therefore you have that 3. When X is 1 and Y is 2, X minus Y, we expect it to be negative 1. Therefore that is 2. Negative X plus Y When x is 1 and y is 2, we expect this one to be 1, positive 1. That's 2. And if when x is 1 and y is 2, we expect 2 plus 6, which is 8. So all these are now have been transformed to the basis of G, and therefore that becomes true. That becomes true. Okay. For E2, same technique, and we have that. Remember what I've just said? If you have a question on this, kindly leave a comment. Comment there, ask me a question. I'll respond as quick as possible. Okay. Remember also to subscribe to this channel if you have not yet subscribed to this. Okay. So this is linear algebra. Linear algebra. So now we have said these solutions, the output create rows. Remember, create columns. So this one is such as that one, 3, -1, 1, 8, and the other one is 1, -1, 1, 3, and this is actually a matrix. It's actually a matrix. Okay. Now the next one is now the transformation of SOT. SOT. Remember we had done SOT. If you look at the first thing that we did in A, is actually SOT. What we did not do is that we did not use the basis in the transformation. So what we need to do is to introduce transformation to this. So SOT, we generalized. So instead of using x, y, z as per A, we are using now the basis for f. The basis for f1 is 1, 1, triple 1. The f2 is 0, 1, 1, and the last base is 0, 0, 1, 1. Then after transforming with t, the solution that you get after t, you transform with s. And therefore, the reason you are getting the final being 4, because s is mapping R2 to R4. So x plus y is 7, x minus y is 1, negative x plus y is negative is 1, and 2x plus 3y is 7. All these makes columns for the matrix. So that gives this and that. Remember what you have said? If you have a question on this, don't worry, just leave a comment and I will be the first person to respond to you. You also have a question that you need me to look at, just leave it at the comment. I will check it out. Okay, now having done that, SO2, we want to show that this one, SO2, this one is same as this. So we know S being mapped from E to G, we know that. And we know T to F to E, we have already done that, start. And this just becomes normal multiplication of matrix. You know that from basic math. So that is true. And if you compare this with what we had done, you find that is true. So that's basically true. It's okay. So far so good. If you have a question, leave it as a comment. Subscribe. I will be grateful to answer you, to respond to your questions and also observations. Okay, for now, subscribe now and remember to share.